Okay, this is a question from the review packet that's dealing with intersections between planes and stuff like that. This is from a part B because it's a little bit long, but we're just going to go through it to make sure that we fully understand it. So we've got those three planes. We need to show that they do not intersect. Basically, we just need to eliminate some variables. If we start with 2x minus y plus z equals 4, and x minus 2y plus 3z equals 5. I'm going to use just elimination, just simple elimination to make this quicker. We could use Gaussian row reduction, but I think that's just going to make our lives more complicated. So if I multiplied this by negative 2, I'd be left with negative 2x plus 4y minus 6z equals negative 10. When I add these together, I zero out my x, which is what I'm after. I end up with 3y's and negative 5z's, and this is all going to be equal to negative 6. So I've eliminated x, now I just need to eliminate x again. So I can pick any of the two. I'm going to pick my second one, which is x minus 2y plus 3z equals 5. And then I'm going to do the third one, so negative 9x plus 3y minus 2z equals 32. Well, the easy way of combining those two is multiplying this one by 9, because again, I got rid of the x in that first one, so I need to get rid of the x this second time as well. So if I did that, I'd be left with this new combined one is going to be 9x minus 18y plus 27z is equal to 45. That's pretty ugly, but it's doable. So I'd end up with negative 15y plus 25z's is equal to 32 and 77. Ugh. All right. Now I'm going to take these two and I'm going to eliminate another variable here. So let's just see what happens when I do that. So if I have negative 15y plus 25y is 77, 25z, sorry, and 3y minus 5z is equal to negative 6. Well, to get rid of those, if I multiply this by 5, I'd be left with 15y minus 25z is equal to negative 30. Combining those, I end up with 0, 0, and 47. Well, that right there is a contradiction. So if there's a contradiction, it means that at least one of the planes is parallel to the other. They don't intersect at all. So we've got this is no intersection. If we ended up, so this contradiction means that there's parallel going on. If we ended up with a row that was 0, 0, 0, that would mean that the planes are right on top of each other. Okay, that's doable. Let me get this all out of the way so we can do the next part of the problem. All right, then we need to check that point is on both of the first and second planes. Well, to check to see if a point is on a plane, all we have to do is substitute that point into the plane. So to check for plane 1, it's 2 times 1 minus negative 2 plus 1 times 0, and we're checking to see does that equal 4 or not. Well, 2 plus 2 last I checked, is still 4. For plane 2, we are doing, we're doing 1 times that minus 2 plus 3 times 0 is this 5. Well, 1 plus 4, again, last I checked, is in fact 5. So we've got both of those done. Then find the vector equation of the line that exists between those two, between 1 and 2. All right, well, the easiest way of doing that, well, let me get this out of the way. The easiest way of doing that, that's annoying, is for me just to, I'm just going to find the vector product between the normals of the two planes, because that's where that would be. So the normal of this first one is 2, -1, 1. And I'm crossing that with 1, -2, and 3. And then we just have to do the vector product. Just to make this video faster, I'm just going to do that on my calculator. So I need the cross product of, and I know you don't have access to this in your exam mode, but I'm lazy. My numbers, where did they go? Sweet, so I've got 2, -1, and 1, and I have 1, -2, and 3. When I do that, I get the cross product is -1, -5, -3. We know that the intersection is going to be at this point. Like, this point is on both planes. So if it's on both planes, then it has to be part of the intersection. So my vector equation of the line is going to be that point, 1, -2, 0, plus some constant times -1, -5, -3. So that's the vector equation of the line. We got it. We're good to go. Okay. Now, the next part of this problem says that we have to figure out the shortest distance between that line, that intersection line, and a point, and that plane. So to do this, again, we're having to imagine that we've got this plane, and then we've got another 2 planes that are intersecting at a straight line there, and we're finding this distance right here, that distance between those lines and that plane. Okay, so to do that, we need to have another vector equation of a line, because if we're going here and it's the shortest distance, then it has to be perpendicular. Specifically, it has to be perpendicular to that plane there. Okay, so the point that the line that we're going to have is going to be 1, -2, 0, because that's a point that we know is on this line. It has to be there. And we're going to add that to some other constant. I guess I'll use mu times, and the direction of this is in the direction of the normal. Okay? This can be now generalized so that any point on this line is 1 minus 9 mu's, sorry. and then -2 plus 3 mu's, and then -2 mu's. So that's my x-coordinate, my y-coordinate, and my z-coordinate. All right. So in order to figure out what that mu is, I'm going to figure out where does that any point on that line connect here. So this is what we're finding. So I'm going to insert this into here. So doing that, I would end up with -9 times 1 minus 9 mu's, plus 3 times -2 plus 3 mu's, minus 2 times -2 mu's. And all of that has to be equal to 32. Expanding my brackets, I'd have -9 plus 81 mu's. I'd have -6 minus 9. Yeah, minus or plus 9 mu's. And then I would have plus 4 mu's. Plus, yes, equals 32. Adding these together, 81 and 9 is 90, and 4 more is 94. And minus 15 equals 32. 94 mu is the same as 47. Mu equals 47 over 94, which is 1/2. All right, so we know that this line intersects this plane when our mu is 1/2. So now all I gotta do is apply that 1/2 to these general things here. So my coordinates of that point would be 1 minus 9/2, and then -2 plus 3/2, and then -1, because 1/2 times that gets me to there. All of this results in -7/2, -1/2, and -1. So the distance between this point and this point is what we're after. So if I set that up, I would have the distance is the square root of 1 plus 7/2 squared, and plus -2 plus 1/2 squared, and, well, 0, and, oh my goodness, that is psychedelic. Let me just slide over. And then 0 minus 1 is just -1. So -1 squared. Combining these, that would turn into 81 over 4. And -2 is -4/2, which would give me, or 9 over 4. Okay, that's not bad. And this would just be 1. Combining these, I get the square root of 94 over 4. Well, I can't take the square root of 94, but I sure can take the square root of 4. So square root of 94 over 2 is our distance between the two lines. I really hope that was helpful.